this programme, we are going to discuss space art in a way we've never really done before, and we're delighted to have with us Britain's most famous space artist, David Hardy. David, after we've shown many of your paintings on our programme, this is the first time you've joined us in person.
It's a great pleasure to be here.
Delighted to have you. And we go back a long way. Remember this book?
I do indeed, yes. That's Sons, Myths and Men from 1954. I was 18 when I did those illustrations, and I was just due to go into the RAF for National Service.
Very good illustrations too.
Thank you.
Well, what first drew you to space art?
I suppose it's just that I looked through telescopes as a boy and a teenager, mostly telescopes made by friends, because I never got around to making one myself. And very soon, rather than looking at a little flickering disc, I began to wonder, well, what would it be like to actually go to those places and stand on the surface? And I started painting my ideas of them.
Were you actually trained as an artist?
Not really. I'm just what you could call self-taught. I did go to the College of Art in Birmingham for a couple of years on a part-time basis, but I actually learned illustration by working at... I was born in Bourneville. I worked at Cadbury's doing chocolate boxes.
Well, it certainly worked out. Now, David, we've got some magnificent pictures of yours here. Let's now see some. In other words, let's have a picture show.
Well, we'll start with going back into space art to its very earliest days. And James Naismith used to make models of in plaster of Paris of the surface of the moon, and then photograph them against a black starry background, and that's what we see on the screen at the moment.
1874, and of course in those days we thought the moon was rather a different kind of world. The mountains aren't nearly so sharp as that.
No, but that was really the model for the moon, sharp, jagged mountains, because of course there was no air on the moon, no weather, no water, and therefore it was thought that the mountains must be as sharp as the day they were born.
Well, what next?
And this one goes through onto Chesley Bonestell, who is probably the best known of all space artists. And he also painted the moon with very sharp, jagged mountains, but he had a very photographic technique which impressed me greatly. And in my early days, I was trying to follow in his footsteps. Everyone was impressed by his work because he just felt that there were photographs of places we couldn't go to yet. This is also Bonestell. This is one of his typical pictures from the Collier's series that he did in 1950.
A lunar crater.
A lunar crater with a convoy of tractors descending into it, and the whole scene's illuminated by earthlight, which he shows as being greeny blue. And the sun is rising on the distant ring wall, brilliant sunlight on the distant ring wall. Very typical. And it's this kind of picture, I think, that really led to the Apollo program, because it so influenced the American public and then later the rest of the world, that people just wanted to go to the moon. And when Kennedy announced that we were going there, you know, it was very largely because of this kind of picture.
It's pretty accurate. After all, if you're going to be a space artist, you must be an astronomer too, which you know very well, David.
Indeed, yes. The artist who really got it right, even before Bonestell, was Lucien Rudeau.
Yes, I knew him.
Yes.
He was a great observer of the moon.
Indeed, yes. He was the director of the Dorneville Observatory in Normandy in France, and he often observed the limb of the moon, the edge of the moon, and he could see that the lunar mountains are actually quite rounded. And of course that was the way he painted them. He used a rather watercolour sort of a technique artistically, and painted quite small, the same size as his pictures appeared in the books, in fact. But as you can see in there, his impression of a lunar crater is quite different from Bonestell's.
Oh, quite different, yes.
Also in the 1950s, I was influenced by R.A. Smith, Ralph Smith.
Whom I knew very well. He and I were on the Council of the British Interplanetary Society together for a long time.
Indeed.
He was an engineer, of course, and it shows in his drawings.
Yeah, I mean, he was able to design his own space vehicles. He designed something very similar to the space shuttle, which he called a ferry rocket, with sort of delta wings. And this is his impression of a lunar landing. And rather than the very streamlined winged spaceship that Bonestell showed, he actually shows a vehicle which is much more like the Apollo lander, with landing legs, shock-absorbing landing legs.
Much more practical, because he was an engineer.
Indeed. That's a painting I did in 1965 of Ranger 9, which is the last of the series, crashing into the crater Alphonsus.
The idea being that stage, of course, to get pictures right up to the last moment, and then no soft landing, just destroy, but get the pictures first. They did.
We got pictures right up to just to a metre or so across, just before he crashed into the surface.
A big crater there, over 80 miles across, with a majestic central peak and wheels on the floor. Now we have a lunar base. Your idea of a lunar base, David?
Yes, it's a picture I painted for the Newsround book of space, actually, a book that was voted the best book of the year by children at the time. And it shows an advanced lunar base with a mass driver for propelling lunar material out into space to build public space stations out there.
I wonder how near the truth that's going to be. I think if anyone's doing the sky at night in 30 years, they may look back and say, It was rather like that.
Well, I hope so, because I mean, at the moment we've come to rather a standstill, haven't we? Especially as far as manned space travel is concerned. We've got a space station up there, but by now we all thought that we'd have bases on the moon and even possibly even Mars.
I know.
It's very, very slow.
I know, but it'll pick up again.
Mm. This is another version of a sort of lunar base. This is by Pat Rawlings, a very well-known American astronomical artist. And he works on computers. He uses what we call 3D programs. He's able to make models on the computer of these. That's called Nomad. It serves as a habitat and a rover. It's able to move around the lunar surface. But artistically, he's able to simply take a model of that and put it in any position that he likes, just rotate it and so forth.
Something quite different now.
Yes, this is someone who's an artist as well as a scientist, Dr. William K. Hartman, Bill Hartman, who you know very well.
I do indeed.
And because he came up with this theory in 1975 that the moon was created by a Mars-sized body hitting the Earth at a glancing blow, throwing off a shower of debris which went into orbit and eventually coalesced into the moon.
I wonder how accurate he is. We may know one day, but not yet.
Well, it's widely accepted, but that doesn't mean he's right, of course.
No, it doesn't. But he's a very good artist.
That's a painting by himself of his theory, anyway.
Now we go further afield, the strange little world of Mercury.
Yes, I thought we'd do a bit of a tour of the solar system, starting from the sun and moving outwards. And this is a Chesley Bonestell painting of Mercury.
Airless, waterless, lifeless, a strange little world. Not easy to see, either.
Quite similar to the moon, really, which is how he's portrayed it.
And a very, very hot surface.
Very hot.
But not so hot as our next world, Venus.
No, that's where we've got a runaway greenhouse effect, isn't it? Because that's how Ludek Pesek painted it in the 1970s.
Venus looks so lovely in the sky, like a small lamp, as it has been earlier this year. But, we thought it might be a rather welcoming kind of world, but it's anything but that.
When we first met, there were two options, in fact, or possibly even three options. There was one where it was a planet rather like the Earth in the Carboniferous era with jungles and so forth. Or it might be just a wind-blown desert with dust eroding rocks into strange shapes and so on. Or it might even be an ocean. And I think, as you said in one of your books, it would be an ocean of soda water because the carbon dioxide in the atmosphere would be dissolved in the oceans.
And if life on Earth began in the seas a long time ago, if Venus had been like that, then life might have started there. But sadly, it's not, and that's a much more accurate representation.
No, it's an actual hell planet. It's, as you know, the clouds are made of sulfur dioxide, sulfuric acid. It's extremely hot, even hotter than Mercury because of this greenhouse effect inside the atmosphere.
Now we come on to Mars, and this is the year of Mars. The Beagle 2 probe will go off with any luck at all, and we may find out if there's any trace of life there. I wonder. The jury is still out. Anyhow,
would be
there's
nice.
Mars for you.
Well, that's Mars seen from its moon Deimos, as painted by the French artist and astronomer Lucien Rudeau. And what's particularly interesting about this is the fact that it shows Mars in a crescent phase, which is something you can never see through a telescope. But Rudeau, as an observer, realised that although Mars, Jupiter, Saturn, all the planets beyond the Earth can only be seen in more or less full phase through a telescope because they're further from the Sun than we are, if you're on one of the moons of one of those planets, then of course it would go through all its phases, right the way from crescent through to half, through to gibbous, full and back again. That's a painting I did, and it shows an expedition leaving a base on the pole of Mars to cross the pole on skidoos.
Turning in Mars, Mars does have ice caps on the pole.
Oh, yes.
Not quite the same as our ice, but ice nevertheless, and very chilly.
Some carbon dioxide mixed in with it as well. That's at sunrise, of course, so you can see some clouds are there. That's a painting I did of a Mars lander called an aerobreaker. It's a kind of a clamshell that opens and to allow you to see what's contained inside it. It's landing there in a Martian riverbed, really, I suppose, isn't it?
There certainly are old riverbeds there, so Mars did once have a lot more atmosphere than it has now, and almost certainly running water too.
Yes, I think so. Moving out to Jupiter's satellites, one of the most fantastic ones is Io.
Io, a bit bigger than our moon, a reddish kind of world, highly volcanic.
Highly volcanic.
And of course moving right inside Jupiter's lethal radiation zone.
Yes.
I'd like to go there.
It's not a place that I'd want to go and sketch, but obviously Ludek Pesek did, as he did in that painting there. The volcanoes look like parasols. They explode outwards hundreds of kilometres and they form domes or parasols of gas. We used to think, when they were first seen in 1979, was it?
Yeah.
Yes. That they were quite cool volcanoes, just formed by sulphur, but nowadays we know they're extremely hot.
Very hot indeed.
Superheated, yeah, quite amazing. That's a digital picture by Don Davis showing Io in the foreground and Jupiter behind it, and you can actually see some of the plumes of the volcanoes on the edge of Io. This is a Lucian Rudo painting of Saturn seen from the planet. There's no surface of Saturn as such, of course, because it's a gas giant. We're looking at through the cloud layers.
The rings being made of course, of millions upon millions of icy particles, all spinning around Saturn like tiny moons.
Yes, we used to think they were much bigger, maybe up to kilometres across, or the size of houses or something. But gradually, as the years have gone by, we've revised our ideas until they're now much smaller.
And of course, Neptune, the next planet,
yes,
that does have satellites, and one satellite is really amazing. Triton, bypassed by Voyager 2 in 1989, and proved to be a very surprising kind of world.
Yeah, well, I was there in 1989 at the Jet Propulsion Laboratory, JPL, and I was able to do some sketches while I was there and then come back and do this painting. On the surface of Triton, we saw these dark streaks, which were interpreted as being caused by geysers erupting, and then dark plumes of material drifting down from them onto the surface.
But not water, liquid nitrogen.
Oh yes, nitrogen and methane.
We breathe nitrogen as a gas. Triton is so cold, nitrogen solidifies, or comes out as a liquid.
Yeah. And of course Neptune is sometimes the outermost planet, because Pluto, which actually is the outermost, sometimes comes within Neptune's orbit.
And is Pluto a planet anyway?
Indeed. This is a painting by Ron Miller, an American artist who's very well known. He's written a number of books and illustrated them with Bill Hartman, in fact. And then finally, as you say, Pluto, which is a double planet really, because it has a very close moon, which is also quite large, even larger in comparison than our moon is
yes,
in comparison with the Earth.
More than half the size of Pluto.
Yes. And they also revolve at a rather strange angle, I think about 53 degrees, is it? So
it is indeed.
They go around, rather
and
than
of
going...
course, a long, long way, even the sun appears as a small but very intense point in the background, as you can see there.
But still giving 100 times as much light as a full moon.
And that takes us to the edge of the planetary system. Now, David, what about the IAAA?
The International Association of Astronomical Artists was formed in 1981 by a bunch of space artists, obviously, and has now grown to about 120 members all over the world. We've got members even down in Argentina and all over the place. This picture, in fact, shows Joel Hagen, who was our vice president at the time, sketching in Utah, in Canyonlands, which is very Mars-like.
So now, anyhow, we've come to the edge of our planetary system. Let's now go further afield. After all, our galaxy alone has 100,000 million stars, and we know many of these do have planets, so there's plenty of scope.
When we did the book called The Challenge of the Stars in 1972, we didn't even know for sure that there were any planets going around the other stars, but we guessed there must be, which is why I did this painting of Proxima Centauri.
4 light years away, 24 million miles.
Yeah, it's a red dwarf star, much smaller than our sun and quite dim. I showed it with the planet going round it in about 10 days, which means there's liquid water there. In the sky, on the right, is the well-known constellation of Cassiopeia, but with an extra star to its left.
Our sun.
Our sun, yes.
Our sun, yes.
But since about 1999, a number of discoveries have been made, in fact, of planets going around other stars. This is the first one that I painted digitally. It's a planet of Tau Boötis, which the press, of course, quite incorrectly called the Millennium Planet because it was 1999.
If we find a planet like the Earth going around a star like the Sun, I'd expect our kind of life, but of course we can't be sure.
No, indeed. And in the sky is a huge galaxy. It could be our own Milky Way, it might be another galaxy, but it would be a wonderful scene, wouldn't it?
Well, it certainly would be. Well, David, you've given us a wonderful tour, both in space and in time. It would be great fun to come back in 50 years to see just how accurate these pictures are. I fear you and I won't know that, but others will. David, thank you very much.
Thank you for inviting me. It's been a great pleasure.
Don't forget our website, www.bbc.co.uk/space, and our CFAX page 620. Good night.